All right, in this problem 1.2.6, write an equation from a graph. We're told a scenic train ride makes trips on an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as a function of time, and what is its domain? All right, so they're looking for us to come up with an equation based on this graph. The main key thing here is this kind of upside down v. That tells me that this is an absolute value equation or an absolute value function, either way you want to look at it. And what that means is my function is going to be in the form a x minus h plus k. All right, and a is going to determine stretches or compressions, h is my shift left and right, k is my shift up and down. Now it's important to note here, and this is the first time this comes up, hk is kind of a shortcut to my vertex. So in this problem, this 15, 15, that's my vertex. So I need to figure out what does A equal, what does H equal, and what does K equal. Okay, those are my big question marks here. I know H and K, based on my vertex, are 15, 15. What I know about A is I know that as A is negative. All right, the reason I know that is my absolute value function has been kind of flipped upside down. Okay, it looks more like an A than a V. So A is going to be negative something. I don't quite know what that something is yet, so I've got to figure that out. And to do that, I can take this equation and I can rewrite it. Again, y equals A times x minus h plus k. I'm going to plug in the values that I know. I know I have a negative A. I know that k is 15. I know that h is 15. I'm going to keep that subtraction sign, that's part of the formula. And now, since I'm trying to solve for A, I need to figure out, all right, what can I do with x and y? Well, convenient thing here is that I also know the point 0, 0 is part of my function. It's on my function graph. Now there's other points I use. I could use like 30, 0 here. I could use points here, but 0, 0 is going to be the easiest. So since I have the point 0, 0, I can treat those as my x and y values. And I'm going to plug those in accordingly. Now I have an equation that only has one variable. So in this form, I can now solve for A, and that's going to tell me what my A value is. So we'll simplify this. We get 0 equals negative A times 0 minus 15 would be negative 15 plus 15. So I have 0 equals, that 15 will come out, right, as a positive 15. I'm going to subtract 15 to the other side. So I get negative 15 equals negative 15A divided by negative 15. So A is equal to 1. Now it's important to note here that A is 1, but I also know it's going to be negative. So here, this A will be equal to, A itself is equal to 1, but we have a reflection. So we're going to say negative 1 there. So what equation represents the function? Well, f of x would be equal to negative 1 times x minus 15 plus 15. This would be my solution here. I know the A part might seem a little confusing. If it seems a little tricky, just watch out for the negative. If you're not sure if in the end it's supposed to be negative or positive, look at your graph. Has it been reflected? Yes, put a negative there. If it hasn't, we'll leave it as is. So that answers the first part. What equation represents the distance from the station as a function of time? They want to know what the domain is. All right, my domain are my x values. And if we're talking about minutes after the ride begins, my domain, well, time, all right? I can't have below 0. So 0 is the minimum value. And then I get back to the station. 30 minutes into my trip. This part right here. So my largest x value is 30, and we're going to include that. So what is the domain? 0, 30. Going back, you need to take a look at this equation right here. Find a, x, h, and k. The next important part is this hk is your vertex. So find the vertex, in this case 15, 15, plug that in, pick another coordinate point on your graph, plug that in as x and y, and then that'll help you solve for the a value. It's a little bit of work, but you can follow kind of that same pattern or that same method for each problem that's set up like this.